Hello students, today we are going to discuss about this testing of hardened concrete, which is most important part of your subject, that is related to checking of strength of hardened concrete once it has acquired certain strength. So basically why this testing of hardened concrete is required. So this is most important, and that plays a very important role in controlling and confirming the quality of cement concrete work. Okay, one of the purpose of testing hardened concrete is to confirm that the concrete that we have used or that we have designed it at site, it has developed the required strength as per our design. And generally, as the hardening of the concrete takes time, it will one will come to know about the actual strength of concrete after some time only. Okay, so same day you cannot find out the strength of concrete. So this is only the inherent disadvantage of our conventional test method, in which we are casting generally the cubes and cylinder or the beam specimen from the representative concrete, or either cutting the core from the actual concrete and testing them up to the failure. So this crushing of the sample is generally called as destructive testing, and that will be useful to determine the strength of different strength of concrete. Also, instead of applying the load to the failure, some other properties of the concrete, they are also estimated, and they are used to estimate its strength, durability, and other elastic parameter, and that in which we are not allowing the specimen to a particular failure by loading them up to the failure. It is called as non-destructive testing. So in general, you can say that there are two types of testing method that are generally used to test the strength of concrete. So first is destructive testing, in which the crushing of sample take place to ascertain the strength of concrete. So there are three methods in this: compression test to check the compressive strength of testing, compressive strength of concrete. By here, the two specimens are used: cubes and cylinder. Next, to check the flexural strength of concrete, here we are casting beams. And third is tensile strength of concrete. So that is generally done by the indirect tension test method, and that is to check the tensile strength of concrete. Here we are casting cylinders. So basically here, in destructive testing, we are casting cubes, cylinder, and beams, and we will check the strength of concrete, and we are allowing the load up to failure. That's why it is called as destructive testing. Next is non-destructive testing. So here, this non-destructive testing consists of the specimen which are not loaded to failure, but attempts are made to measure some other properties of concrete, and from which estimation of its strength, durability, and elastic parameters are obtained. As per your syllabus, these are the methods: rebound hammer test, ultrasonic pulse velocity method, penetration test, and pull-out test that you have to learn. In between, some semi-destructive testing methods are also adopted, but most of the testing method of hardened concrete are of destructive and non-destructive type of testing. So here we are going to discuss about destructive testing for the strength of concrete. So basically it is related to compressive strength, flexural strength, and indirect tensile strength method. So first, we should know which are the specimen which are used. So here in this figure, for the destructive testing, for the compressive strength, generally we are using this cubical specimen. For flexural strength, we are using this beam specimen, and for compressive and tensile strength, we are using cylindrical specimen. So here first we will discuss about compression test of concrete. This is the most important test, because we are generally designing the concrete for the resisting the compressive stresses. And here in this figure, you can see this under compression testing machine, we have kept our cube specimen and cylindrical specimen. So in the compression test, this is the most common test which is conducted on the hardened concrete. Why? Because it is easy to perform, and also it is the desirable characteristic property of the concrete, and that are qualitatively related to its compressive strength. That's why this is the most common test that is conducted on hardened concrete. So here, as we have discussed, specimen used are either cubical or cylindrical. Sometimes prisms are also used, but it is not common in India. So size of this cubical specimen that you should know, that is 15 by 15 by 15 centimeter. But if the largest nominal size of the aggregate does not exceed 20 mm, then 10 by 10 by 10 size of cubes are also used. And the size of the cylindrical specimen, here it is 15 centimeter diameter and 30 centimeter length. So here if you just consider h upon d ratio, height to diameter ratio, just you try to understand height to diameter ratio. In the case of cube specimen, height is 15, diameter means its lateral dimension is 15, so you can say height to diameter ratio is 1. Here in case of cylinder, your height is 15, your diameter is 30, so you can say its height to diameter ratio is 2. So why I'm saying this, because it has a pronounced effect on the strength result. Now for casting this specimen, we need some mold. So these molds, they are generally consisting of steel or cast iron, and it should be thick enough to prevent any distortion. And it should be made in such a manner that the removal of the molded specimen without damage. So whenever we are removing the specimen should not be damaged, and it should be so machined that it is assembled ready for use, and the dimension and the internal faces required to be accurate. So whatever accuracy it is possible, as per the size of the specimen, they should be designed. So here in this figure you can see all these molds. So basically this is the cubical mold having size 15 by 15 by 15 or 10 by 10 by 10 for if the aggregate size is less than 20 mm, you can use 10 mm size, 10 centimeters by 10 centimeter by 10 centimeter cube mold, or otherwise most commonly used is 15 by 15 by 15 centimeter cube mold. And this is cylindrical mold, that is 15 centimeter diameter by 30 centimeter height. So here after whatever as per design, we have to mix our ingredients, that is cement, fine aggregate and coarse aggregate, and as per water cement ratio you have to mix all these ingredients, and compaction is to be applied. So this compaction may be hand compaction or it may be done by vibration. So if you are doing with hand compaction, then you have to use such kind of tamping bar or tamping rods, and you have to apply uniformly all the strokes. Okay, so generally for 15 centimeter cube, the number of strokes should not be less than 35 per layer. So generally you have to fill this mold in layer to layer manner. So for each layer, the stroke should not be less than 35 numbers, and for 10 centimeter cube it should not be less than 25 strokes per layer. Okay, so 15 centimeter 35 per layer, 10 centimeter cube 25 strokes per layer. And if it is a cylindrical specimen, the strokes may be, it should not be less than 30 numbers per layer. And all the tamping should be applied all over your particular cube mold, so that no void should remain there. Okay, so proper compaction is very essential. So if you want a proper compaction, then you can utilize vibration. So such kind of vibrating tables that are available, under which you have to keep your mold, and you can compact it properly by using either vibrating hammer or by using such type of vibrating table or vibrator. So mode and quantum of the vibration in the laboratory, it should be nearly same as whatever we are going to adopt in the actual operation, just to have a representative sample or representative specimen for testing. So here in this figure you can see how we are filling this concrete, how this stamping can be applied if it is a hand compaction, and this is the finished particular mold, and that is you can say specimen. So here basically this beam is shown, that is generally useful for the flexural strength, but this cube specimen that can be utilized for compression test. Next is capping. Basically you have to understand that this capping is related to plainness of the surface, and generally this capping, it is the common way of achieving the plainness requirement, and that is what which is needed for the cylindrical specimen. So you can say that it is only applicable to cylindrical specimen, not the cube specimen. So generally the end of all cylindrical specimen that are not plain with 0.05 mm, that are to be kept, so they have to bring to a particular level of plainness. And generally this capping can be done on the completion of casting, जब हम casting complete कर लेते हैं, or few hours prior to testing. So these are the two time at which you can apply capping, completion of casting or just before, prior to your testing. So generally few materials are used, that is the neat cement paste से कर सकते हैं, cement mortar you can apply, sulfur or hard plaster can be used. So generally cylindrical specimen, they are kept with the thick layer of neat cement, generally 2 to 3 hours after molding operation is done. And at the top, some glass plate can be applied, so that will bring the plainness to your particular cylindrical specimen. Okay, so this plainness is generally applicable to the cylindrical specimen, which is called as capping. Next is curing. So basically, you have to submerge your specimen in water tank. So storing the specimen at the place for 24 hours plus or minus zero point 0.5 hours from the time of addition of your water to the dry ingredients. So for 24 hours, you have to keep your mold along with your specimen in water. Then after 24 hours, remove the specimen from the mold and keep it immediately submerged in clean fresh water, and keep them until you are taking out just prior to taste. So normally the testing that is generally done after 28 days. Okay, so generally 7 and 28 days, that are the time when we are going to taste the specimen. So until that, we have to again submerge the specimen. So you have to take out specimen from the mold after 24 hours and keep it in the particular curing tank. So water in the curing tank, it should be fresh. So for that, every 7 days it should be renewed. After that, you have to take out your particular taste for actual testing. So generally this age of testing, it is done after 7 days and 28 days, but this 28 days strength, that is considered to be your final characteristic strength. So the days being measured from at the time you are adding your water to the dry ingredient. And generally we have to taste 3 test specimen at a time, and you have to taste the specimen immediately after removal from the water, still in wet condition. So you should not take out the particular specimen and allow it to dry for 1 hour 2 hour like that, but just you have to take out the specimen from the curing tank, wipe off the surface, and just allow it to taste under compression testing machine. So if the specimen are received dry in the dry condition, then keep in water for 24 hours before testing. And why we are doing in wet condition and just wiping off the surface, just to avoid the different degree of dryness. Okay, so just you take out the specimen, test under the compression testing machine. So placing the specimen in the machine. So once you have taken out your particular specimen, you have to place your specimen under compression testing machine. So generally in the cube specimen, they are tested on the opposite side of the cube. So generally we are casting, suppose cube in this direction, we have to check or we have to apply the load in this direction, means we have to rotate this. Okay, so casting is done in this direction. So suppose this casting is done in this direction, but we are applying the load in opposite direction. So that is the method in which we have to test the cube specimen, while in the cylindrical specimen, load, that's casting and loading, they are done in the same direction. So generally you have to align this cube specimen or cylindrical specimen at the center, and you have to slowly apply the load at certain uniform rate until the cube breakdown. So you have to observe how it is filling, whether the aggregates are coming out or cement paste separate out from the aggregate. And precautions should be kept so that the load is applied at the center only, because slight eccentricity can also result in some serious deviation in your results. So ultimately when we are loading and we are compressing, at the moment it will break down. Okay, so that point in at which it will fail, that maximum load, that you have to note down. Okay, and that load at failure of the specimen for area under compression. So generally, as you know, the size of specimen, it is 15 by 15 centimeter. So area under compression is 15 by 15 centimeter square. So this load at the failure divided by area under compression, that will give you compressive strength, load by area. So that will give you compressive strength of concrete in Newton per mm square. So by this way you can check the compressive strength of concrete. So it's a very easy and common method in which we have to as per our design we have to decide our proportion of cement, fine aggregate, coarse aggregate. You have to properly compact it, then after you have to cure it, and then after you have to check it under compression testing machine and load at failure to be checked, and P by A that will give you your compressive strength of concrete. Now how this failure of compression specimen take place, that is very important, because this is affected by few parameters. So basically this compression test, it develops a very complex system of stresses. It's not that much easy कि compression apply कर दिया तो पूरा compression में है. So basically due to compression load of either cube or cylinder, they will go under lateral expansion. So ये पूरा lateral expansion होगा. Either it may be cube or cylinder. But the steel plates, here you can see at top and bottom, these steel platens, that will not undergo lateral expansion. उसका तो कोई lateral expansion नहीं होगा. So what they will do, this steel, it will try to restrain the expansion tendency of the concrete in the lateral direction. So it will try to restrain it कि वो जल्दी से वो laterally expand ना हो. Okay, so it will induce a tangential force between the end surface of concrete specimen and the adjacent steel platens of the testing machine. So some tangential forces will be developed between this specimen and this steel platens. And generally this lateral strain in the steel platens is only zero point 0.4 of the lateral strain in concrete. So it will try to restrain the lateral expansion of your particular specimen. And as this steel pattern restrain the lateral expansion of the concrete in the part of specimen near its end, तो एंड पे ज्यादा इफेक्ट आएगा, यहाँ पे वो that it will try to restrain. So this two area which are nearby your steel platens, so they will be more affected, that will be more restraining effect is observed. Okay, so the degree of restraint that exercise depend on the friction which is actually developed. And with friction acting under normal condition of test, the elements within the specimen subject to shearing stress also apart from compression. So it's a complex system of stresses which is developed under compression testing machine. So the magnitude of the shear stress decreases and the lateral expansion increases in the distance from the platens. जैसे जैसे आपका प्लेट से डिस्टेंस बढ़ता जाएगा वो इफेक्ट कम होता जाएगा. ठीक है. So as a result of the restraint in the specimen tested to the destruction, there is a relatively undamaged cone of height equal to root 2 by root 2 3 d, where d is the lateral dimension of the specimen is observed. So if you just multiply it, it will be around 1.4 d. Okay, so it is 1.4 d. So you can see that if it is a cube specimen, there would be some undamaged cone that is observed at top and bottom, and some cracks are observed here. So this undamaged cone, it may be around root 2 into 3 into d. So if the specimen which is longer than 1.7 d, a part of it will be free from the restraining effect of the platens. So 1.4 d tak to maximum effect hoga hi hoga, but if you are keeping more, okay, that is 1.4 d kar rahe hain, so that will be less affected by the restraining effect. So specimen whose length is less than 1.5 d, it shows a considerable higher strength than those with a greater strength. Why? Because more restraining effect is observed at top and bottom and undamaged cone is observed. So here in this graph, you can see the relative strength versus height to diameter ratio. So just correlate it with this 2 height to diameter ratio and 1 height to diameter ratio. So this represent your cube. This is just like cube because its height to diameter ratio is 1, and this represent your cylindrical specimen because its height to diameter ratio is 2. So here you can see its relative strength is nearly equal to whatever we should get. But in case of cube specimen, it is giving some higher value. So you can say that cube strength would be more as compared to cylindrical strength. Means it is giving more value. Okay. So its relative strength that we are getting, it would be more as compared to cylinder. So here, what would be the effect of height to diameter ratio on strength? So normally, height of cylindrical specimen H is generally made twice the diameter D. And sometimes when you are cutting the core from the road pavement or airfield pavement और फ्रॉम फाउंडेशन, जो भी आपका पेरेंट कंक्रीट है उसमें से अगर आप कोर कट कर रहे हैं, सो वी शुड ट्राई टू मेंटेन दिस हाइट टू डायमीटर रेशियो एज 2. And this diameter of the core, it also depends upon the cutting tool as well as thickness of the concrete member. And sometimes it may be possible that you cannot maintain it, so but just try to maintain this h upon d ratio as 2, because it is nearly giving relative strength 1. Okay, so if too short a core, it is necessary to estimate the strength of the same concrete as it had been determined in the specimen with h upon d ratio equal to 2. So try to get h upon d ratio as 2, and if it is not possible, then some correction factor are to be applied. So here this figure shows the factor of height to diameter ratio of a core. So this correlation factor is not constant, okay, but it differs in different strength level of concrete. And from observations and experiments, it is shown that it is high strength concrete which is less affected than the low strength concrete. So just try to understand using this graph. It is the relative strength, and this is height to diameter ratio. And here this is 52, it is a high strength concrete. That's 14, it is low strength concrete. So in all the cases of all the height to diameter ratio, the relative strength here, suppose this is height to diameter ratio 1, then it is less affected. This high strength concrete is less affected, it is giving somewhat 1 relative strength, while in case of this height to diameter ratio 1 and this low strength concrete, it is giving around 1 uh, 38 or 39, like that. So here you can say that high strength concrete is less affected by h upon d ratio. So accordingly you can apply the correction factor. So this second figure shows the influence of h upon d ratio on the strength of cylinder for different strength levels. So here you can see this correction factor is 1. So relative strength is 1. So the correction factor is 1 only. But while in case of h upon d1, it is 0.88. So you can say that whatever strength we have obtained in cube, if it is having h upon d ratio 1, then we should multiply it with 0.88 to get the actual strength of concrete, because it is giving higher value due to restraining effect of steel platens. So definitely this cube and cylinder strength would be different for the same concrete. So the restraining effect of the platens of the testing machine extends over the entire height of the cube, but it leaves the unaffected part of the test cylinder because of its greater height, and therefore the strength of the cube made from the identical concrete will be different from the strength of cylinder. So you may not get same strength of the same concrete for tube specimen as well as cylindrical specimen. And normally the strength of cylinder is generally taken as 0.8 times the strength of क्यूब, बिकॉज क्यूब इज गिविंग हायर वैल्यू, तो उसका 0.8 टाइम्स जितना वैल्यू सिलेंडर में आता है. बट देर इज नो यूनिक रिलेशनशिप बिटवीन द स्ट्रेंथ ऑफ क्यूब एंड सिलेंडर. इट ऑल्सो depends on the level of strength of concrete, and for high strength the difference between the strength of cube and cylinder is becoming narrow. जैसे जैसे high strength concrete होता है उसका इफेक्ट कम होता जाता है, and it is observed that around 100 megapascal concrete, the ratio may become nearly equal to 1. So either you cast cylinder or either cast cube, both will give you similar result. So this for following table, it shows you the pattern of cube and cylinder. So here you can see this, the ratio of the strength of cylinder to strength of cube, it ranges from 0.77 to 0.96, and as the strength value, compressive strength value increases, this ratio is also becoming narrower. So here if you want to compare between the cube and cylindrical strength, then there are few points that you should understand. So it is difficult to say that whether cubes are giving more elastic strength properties of concrete or cylinder is giving more better result. But it is said that cylinder is less affected by the end restraints, and which is caused by the steel platens. Hence you can say that cylinder are giving more uniform results than cube. So that's why this cylinder is becoming more popular in the research laboratory. Also, these cylinders that are cast and tested in the same position. While in case of cube, as I told you that it is casting is done in one direction, tested from the other direction. So in actual structure also, this casting and loading is in same direction. So as far as the loading is concerned, this cylinder, it simulates the condition of actual structural member, which is in favor of the cylindrical specimen. ओके कि भाई फील्ड में भी वही होता है जहाँ पे आपका लोडिंग होता है, इट इज इन द सेम डायरेक्शन, दैट्स वाई दैट विल फेवर दिस cylindrical specimen. So this favor of the point in the favor of the cube specimen is that its shape. So whatever shape of the cube, it resembles the shape of the most of the structural members. That's why the shape of the cube that will make it favorable for the cubical specimen. Also capping. Okay, so a cube does not require capping while cylinders require capping. So whatever material that we are using as a capping and to in case of the cylinder, that may also include some extent of the strength of the cylinder. So these are some of the points that you should know related to compression test. So this all this all related to this compression test you should know is testing method, how the particular test specimen fails, what is the effect of height to diameter ratio, why the strength of cube and cylindrical strength that are different, and what are the reasons behind that. Okay, so thank you very much all of you, and these are all the points which are very essential as far as the compression test of concrete is concerned. In the next class we will be discussing about flexural strength and tensile strength of concrete. Thank you very much.